This is my final device for the water level monitoring system. It uses an ultrasonic sensor to measure how full a tank is and displays the water level as a percentage on an LCD screen. When the water level drops below a certain threshold, a status LED begins blinking to indicate a low level. The entire system is self-contained, powered from a single input, and designed to be clearly mounted onto a tank. The goal of this project was to create a simple, clear, and reliable way to visually monitor water level without needing any moving parts or direct contact with the water. The prototype is built around an ATmega 328P microcontroller, which acts as the control center for the system. Power is supplied by a 9-volt source and regulated down to 5 volts using a linear voltage regulator. The regulator ensures a stable voltage for the microcontroller, sensor, and LCD screen. Decoupling capacitors are placed on both the input and output of the regulator to reduce noise and prevent voltage fluctuations, which is especially important when using sensors and communication devices. The ATmega 328P is wired with its power, ground, and reference pins connected to their appropriate rails. The reset pin is pulled high to allow normal operation, with a PBNO connected to ground, so when pressed, resets the microcontroller. The crystal oscillator provides an external clock source for stable timing, with both its pins connected to 2 picofarad capacitors to ground. The HC-SR04 ultrasonic sensor communicates with the microcontroller using 2 digital pins. One pin is used to send a trigger pulse, which tells the sensor when to emit an ultrasonic burst. The second pin listens for the echo signal, which stays high for a duration proportional to the distance to the water surface. By measuring this time delay, the system can determine how far away the water is without making physical contact, using calculations in the code. The LCD screen uses I2C communication, which allows it to operate using only 2 data lines in addition to power and ground. The SDA line carries data, while the SCL line provides the clock signal. This greatly reduces the number of pins required to complete the parallel communication, leaving more pins available on the microcontroller for other components. Next, a status LED is connected through a current limiting resistor to one of the microcontroller's digital output pins. This LED provides a visual warning of when the tank drops below 20%. As shown right now, when the microcontroller realizes that the tank is below 20%, as shown here, this status LED turns on. This LED right here is just meant to show that power is being run through the power rails and is powering the chip. There are several parts to the design aspect of this project, including the PCB, which has several minor changes from the breadboard prototype, including the chip seat and 3x2 header. And this first case is for the LCD display and breadboard prototype, which has a power jack in the side, allowing for the 9-volt input to all systems, and a hole in the side, allowing for the 4-core wire to be run out. On the bottom, we have 2 holes going through for wires to the LCD and to the HC-SR04. And the second case here is to protect the HC-SR04 from humidity or conditions in the cistern. There is a crystal protector and 2 side holes which allow for it to be screwed in the top of the tank. There is extra depth on this side, allowing for these wires to smoothly fit against the wall.